Okay, 7.5. Solve problems involving right triangles. So you are you're experts in figuring out, oh, there's a right triangle. I can use my primary trig ratios, SOHCAHTOA. I can use sum of interior angles, and I can use Pythagorean theorem. They're used in lots of areas. You have a little note there that says this is used in architecture, engineering, astronomy, medicine, and criminal detection. What are the primary trig ratios? Yeah, SOHCAHTOA. Okay, so whenever it's asking that, sine of angle theta is the ratio of opposite over hypotenuse. The cosine of angle theta is the ratio of adjacent over hypotenuse. And the tan of angle theta is the ratio of opposite over adjacent. And again, it matters which way you're looking at the triangle. Okay, if you're trying to find angle A, then you've got op, adj, hype. If you're looking at from angle B, you're looking at op, adj, hype. Okay, so pay attention to that. Now you have another table there. You're going to learn some two new terms which are highlighted for you below. In the first box, you're going to write angle of depression. Okay, depression kind of means going down, right? Going down. So the other name for that is angle of declination or decline. Okay? Yeah. That's what those things are called. Two names for the same thing. What is it? What is it? I'm going to draw the picture first, okay? I'm going to go over to the picture box, draw that for you. And basically what you're going to start with in each of these is you're going to start with a horizontal line. Okay? So in this scenario, angle of depression or angle of declination, maybe you're up here on a mountain, maybe you're standing at a tall tower, a radio control tower or an airplane signal tower, maybe you're in the airplane and you're looking down at something, okay? You might be looking down like that. Yeah? This angle right here, this angle right here is your angle of depression or your angle of declination or your angle of decline. Okay? It is the angle measured below the horizontal. It's the angle measured below the horizontal. So again, that's if you're like standing on a balcony or you're standing on a cliff and you're looking down, or you're in an airplane and you're looking down. Any of those will work, okay? This line is called the horizontal, okay? It's also called the normal. I don't know if we use that word at all, but it can be called the horizontal or the normal. Maybe we'll put that here. The normal. Anytime you hear the normal, it's meaning a horizontal line. Wherever you are, boom, horizontal line. Okay? Yeah, carrying on. That's good enough for that. Our other one is the angle of elevation. Can you guess what the other possible name is? Yeah, angle of inclination. Not like I have an inclination. I'm going to incline. Angle of incline. And to draw our diagram, skip a box, go to the diagram drawing box. Again, we're going to start with our horizontal. And so you're on the ground, or maybe you're still in the airplane, but now you're looking up at a cloud or something like that. But you're looking up at something, maybe at a hot air balloon. And this angle right here, from the horizontal to your line of sight, is called the angle of inclination or the angle of elevation. This is an angle measured above the horizontal. All right? So again, we've already discussed some examples that you can put in the last box for either of those rows. And we're going to get into using these words in problem solving. Okay, just a couple of definitions. In the end, we're going to be using the exact same strategy, SOHCAHTOA, so I'm going to leave that up there, but I'm going to erase the rest of this. Angle of depression is the angle going down from the horizontal. Angle of elevation is looking up from a horizontal.
The thing is, if you're on an airplane, you're looking up.
All right, in example 1 there, we're talking about angles of depression and elevation. And I see three triangles, I see a bunch of triangles, okay? But we're only talking about right angle triangles, and you can see that the information that we need is involved in right angle triangles. So we've got Kim and Yuri. They live in an apartment building. They are 30 meters apart from each other, okay? So in your diagram, they've given you a nice little this to this is 30 meters, okay? What's going to happen? Well, the angle of depression from Kim's balcony, which is over here, to the base of Yuri's building is 40 degrees. Now, if we're talking about angle of depression, you probably already have a pretty good diagram there. I need to remember that I have my horizontal here, quite often indicated by a dotted line. And I'm looking down at the base of Yuri's apartment, and I'm getting this angle of depression. So this right here is 40 degrees. That's what I have so far. The angle of elevation from Kim's balcony again to Yuri's balcony is 20 degrees. So here's my man Yuri, and a 20-degree angle of elevation. Since this is the horizontal and we can trust that buildings are, perpendicular to the ground, parallel to each other, that means I have 90-degree angles here. Here's Kim's building. Here's Yuri's building. Here's a cloud. Excellent. What are we trying to find out? How high is Kim's balcony above the ground to the nearest meter? How high is Kim's balcony above the ground to the nearest meter? Now, a little bit of a trick here. Two things. We were given this triangle, right? If I want to find Kim's height above the ground, I'm actually looking for this distance. Couple different ways I can do this. I can, because I'm so smart, understand that this height is actually the exact same as this height. So instead of using this triangle, which I don't have any information for, except for this 30 meters, I could use this triangle, which I do have this line, 30 meters, and this angle, 40 degrees. The other thing I could do is use what I know about angles from 7.0, and I can say, oh, if this is 40, this must be 50, because they're complementary. Or I could say, oh, if this is 40, then this one must be 40, because of alternate angles. So again, a couple different ways that you could do this. We're going to look at this triangle that we have lots of information for. We're going to actually get this height right here, okay? And we're going to just call it lowercase k. And that's going to give us the height of Kim's window, Kim's balcony above the ground. Which ratio? Which ratio am I using? I've got, well, if I'm looking for here, from here, I've got this side length, which is adjacent, and I've got this side length, which is opposite. So I'm looking at using tangent. The tangent of angle K, capital K.
What do you mean you have that side?
Op over edge. I know angle K is 40 degrees. I know this side length, because it's the same as this side length.
Yeah, but you don't know the
It's 30 degrees. That's my adjacent, and my opposite is K.
Oh.
Solving for K, multiply both sides by 30. K equals approximately 25.17. This is all measured in meters. So Kim's balcony is about 25 meters above the ground. That's A. B. How high is Yuri's balcony above the ground? Well, I don't have the math skills that will allow me to go straight from the ground to Yuri's balcony. But I do know the height to K, and so if I use this top right angle triangle, I can get the rest of the way from Kim's balcony to Yuri's balcony. I know this side length, and I'm looking for opposite. So I'm looking at tangent again. I've got the tan of K, and this time I'm looking at the angle of elevation from K, whereas last time we were looking at the angle of declination from K. Angle of elevation, anyway, op over adj. So the tan of 20 degrees is equal to, I don't know this height, okay? Let's just call it h because it's the missing height. And I do know this is 30. So now all I have to do again, multiply both sides by 30. That gives me the height from Kim's balcony to Yuri's balcony is about 10.92. I'm going to save those decimal places because that's not really what the question was asking. It wants the height of Yuri's balcony. So Yuri's balcony, the height of Yuri's balcony, let's just call it lowercase y because it's a side length, is actually going to be k plus h. So you get up to Kim's balcony at 25 meters. You add the height between the balconies at 11 meters, and you're at a height of approximately 36 meters. Okay, you'd end this with a statement that says Yuri's balcony is about 36 meters above the ground. Over here, for Kim's balcony, you'd end it with a statement that says Kim's balcony is about 25 meters high. Okay, again, identifying right angle triangles, looking at the information that you have. What can I use? What am I actually trying to find out? Here we didn't need Pythagorean theorem or the sum of interior angles, but those are tricks up your sleeve as well. Okay, let's look at example 2. In example 2, it's a 3D picture. Okay, so if it's tough to see, you can look at that. You have a triangle that is standing straight up, XCF, going up the cliff. And you have a triangle that's laying flat on the ground. XYC is laying flat on the ground. Now, because of the way that diagrams are, you know, you're doing a 3D diagram on a 2D page, does that right angle look like a right angle? Neither of them look like right angles, okay? But they are, because we know that there's a little square there. It tells us that they're right angles. So here we go. We have a theodolite. It's an instrument used by a surveyor to measure horizontal and vertical angles. Measurements are taken in order to find the height of a cliff on the other side of a river as shown. Find the height of the cliff to the nearest meter. So first of all, we need to look at these. We have two triangles. We're trying to find CF, right? The height of the cliff. Do I have enough information in XCF in order to solve that problem?
Nope.
As in, do I have in any of these trig ratios 2 pieces of information?
Nope.
No, I don't. There's only one thing given there. It's an angle, 61 degrees. So I could think, okay, I'm looking from the 61 degree angle and I want the height of the cliff. That's opposite. So I'm going to end up using either sine or tangent at the end. But what I want to look for in these situations is shared information. Look for shared information. What does that mean? It means look for a side length that's in both triangles. So I'm going to be looking for CX. In order to help me, maybe I just quickly draw that right angle triangle on the ground. It's got a right angle at X. It's got Y and it's got C. This is going across the river. This is like looking at it from the top down. Here's the river. And we're told that XY is 75 meters. And we're told that angle Y is 52 degrees. Do I have enough information to get CX, the shared side length?
No.
Yeah, I sure do. Okay, I've got an angle, so I'm looking from angle Y. I've got adjacent and opposite involved in the situation. So we've got the tangent of capital Y is equal to opposite over adjacent. So I'm just going to name them right away. I've got CX is my opposite, and my adjacent is XY. Plug in what I know. Y is 52 degrees, so tangent of 52 degrees on the left. CX is unknown. XY is 75. Multiply both sides by 75. I'm going to end up with CX equals 75 times the tan of 52 degrees. Chuck that in your calculator. You're going to get that CX is approximately 95.996. So we're going to go with 96 meters across the river. It's quite a large river. Am I done? No. That was just to get me my shared piece of information. So now why don't I go ahead and draw my other triangle? This is now the cliff, okay, from C to F. This is looking across the river from C to X, and this is my this is going to be my line of inclination here, and that's what we've been given as 61 degrees. We now know CX is 96 meters, and we're looking for side length FC or CF, the height of the cliff. Which ratio am I looking for if I have adjacent and opposite? Tan again. So we've got the tan of, I'm just going to skip ahead, 61 degrees is equal to opposite, which I don't know, it's FC, over adjacent, which I do know, it's 96. Multiply both sides by 96. I get FC equals the tan of 61 degrees, which tells me that FC is approximately 173 meters. I'll just write 173.2, and therefore the height of the cliff is about 173 meters. Okay, you have a little couple of notes at the very bottom that I'll do really quickly just as review. It says angles of elevation are measured above
the horizontal.
Above the horizontal. Good. Angles of depression or declination are measured below horizontal. Again, you could draw a quick picture if it's helpful to you. Primary trigonometric ratios can be applied to solve. Yeah, two-dimensional and three-dimensional, 2D and 3D problems involving what? What kind of triangles? Right triangles. Think they're going to be useful for triangles that are not right triangles?
Probably not.
Yeah, no, they're not going to be. There's going to be another trick coming up in Unit 8. Okay. Last note, some complex problems involve working with more than one. Yeah, trigger, or just write right triangles again. More than one right triangle. Dear friends, your practice problems are listed below there. They are from page 348, number 1 through 7, and page 355, numbers 1 through 14.
That was a
Make sure you keep up. We're at